This is the first page of the Chapter 4 practice test for Algebra 2. Number 1 and 2, the directions say name each polynomial by degree and number of terms. So the largest degree on number 1 is 2, so that makes it a quadratic. And there are 1, 2, 3 terms, so it's a trinomial. Number 2, the largest exponent is a 4, so we'll call that 4th degree polynomial. And then it has 1, 2, 3, 4 terms, so it's 4 terms. Jumping down to 3 through 8, the directions say simplify. Your answer should contain only positive exponents. So for number 3, we want to multiply the coefficients. 4 times 4 is 16. We have an m and an m. We add the exponents, so that's m squared, and then n to the first. Number 4, multiply the 2 and the 4 to get 8. Collect all our x's. We have an x to the first and an x to the third, so x to the fourth. We have a base of y. We have a y to the first, fourth, and fourth, so what is that, 9? Jumping down to number 5, we want to take everything in the parentheses to the power of 4, including the 2. So 2 to the power of 4 is 16. And y to the fourth to the fourth, this is power to a power, so you multiply the 4 times 4 and you get 16. Number 6, we have 2 to the second, which is 4, n to the second, which is n squared, m to the second, which is m to the fourth. Generally, we write this in alphabetical order, so this should be 4, m to the fourth, n to the second. Number 7, I see we have some reducing to do. The 4's cancel, the x squareds cancel. Y to the second goes into y to the fourth, y to the second times, so this is 1 over y squared. Number 8. The u's cancel, and one of the v's cancels in the denominator, v to the third. So what's left? 4 over v to the third. Jumping down to number 9. Solve each equation by factoring. It's already set equal to 0. It doesn't follow one of the patterns, but it is easy factoring because it has a leading coefficient of 1. So the square root of k squared is k, and then the two numbers that multiply to get positive 12, but add or subtract to get negative 7 is k minus 3, k minus 4. If you set each of these equal to 0, it's the opposite. So the k's will be equal to 4 and 3. Number 10, already set equal to 0. This is easily factorable, so I'm going to have n plus 7 and n plus 7. It does follow one of the patterns. And we get n equals negative 7 twice. If you want to write it twice, but you only have to write it once. All right. Number 11, we want to set this equal to 0 first, so add 6n and add 5. So we have n squared plus 6n plus 5 equals 0. This is easily factorable to n plus 5 and n plus 1. So our solutions are negative 5 and negative 1. Number 12, we want to set this equal to 0, so add 16 and subtract 10m. And the new trinomial will be m squared minus 10m plus 16. This one is easily factorable to m minus 8 and m minus 2. So the solutions are going to be positive 8 and positive 2. 13 through 16, we want to FOIL these. So we're going to do first outside, inside, last. Number 13, 5x times 4x is 20x squared. Outside is 5x times negative 8, which is negative 40x. Inside is negative 8x. Last is plus 16. Combine these two, so we get 20x squared minus 48x plus 16. I'm going to FOIL this one as well. First is 20a squared. Outside is negative 10a. Inside is 16a. And last is negative 8. Combine these two. So the answer is 20a squared plus 6a minus 8. 15 follows a pattern because we have a plus and a minus, so we can square the 3. So 3 squared is 9. The outside and inside are going to cancel, and then we have a squared, so 9 minus a squared. This one also follows the pattern. So we want to square the 4r. So 4r times 4r is 16r squared. The outside and the inside cancel, and we have minus 9.